Hi there guys, in this video we're going to have a look at some of the basic trig identities that you're going to need. Now if we go back to our unit circle, we know this has a radius of 1, and from the last video we were speaking about this value here being sine theta, and this one, the horizontal distance, being equal to cos theta. Now, and this angle here, that is theta. So if we look at the one we did before, so if we try and apply the tan ratio to this problem, we know that tan theta is opposite over adjacent. We did mention this in the previous video, but it's always good to hear it again. So tan theta therefore must be equal to the opposite, which was sine theta, over the adjacent, which is cos theta. And this is called an identity. And when we write an identity, we actually put a third equal sign underneath. And if we start by looking at what we can do with Pythagoras Theorem, what we know is sine, if we square this side here, so sine theta squared, and we actually write that like this, just to not be confused with if we wrote it like this, sine theta squared, is the theta being squared only? Yeah, it kind of looks like it. We could do that, but then there's loads more writing, so we just thought if we put the 2 there, everyone can understand that's sine theta all squared. So plus the cos theta side squared, so cos squared theta, that would equal 1. And that is also another identity. Now the important thing to say about both of these is this angle, especially in this one, we're in control of the size of this angle, so it could be 20, it could be 30, it could be 40, it could be whatever we want it to be. And what I'm trying to say here is if I change the angle from this to say 2, this would also be identical to 1. Because it doesn't really matter what this angle is, that radius is still going to equal to 1. The important thing is that it's the same angle. You couldn't have 2 theta here and 1 theta here. That wouldn't make any sense because it's not obeying Pythagoras' theorem. So they're the 2 identities that you need to be able to use, and we can manipulate this one pretty easy. So if we just rearrange to make sine squared theta the subject to the formula, that would be equal to 1 minus cos squared theta. And you could do the same with the cos squared theta here, 1 minus sine squared theta. So you need to know these 2 off by heart. Here's just me saying again, with the angles could change. So half theta, that's still identical to 1. The angle doesn't matter, but it must be the same in each term. Okay, it's the same for these. Whatever that angle is there has to be the same here and here. Otherwise that identity is not true. Okay, so we're going to ask you to simplify maybe an expression, or we might use this as part of an equation to solve. And the important thing is there isn't a way to do these questions. There are often more than one way, and it's your job to work out which is the best. So for me, looking at this one, because there is something I can factorize for, I'm always going to go for that. So looking at those, I can see there's a 5. So if I factorize, I get sine squared 3 theta plus cos squared 3 theta. And I can now see the identity that this is equal to 1. So that is the same as 5 lots of 1, which is equal to 5. Now how else could I have done that? Well, when I see a sine squared theta, or 3 theta in this case, and a cos squared, I think, well, it would be in my interest to try and make the same ratio. So I could either make them both sine, or I could make them both cos. Let's go for making them both cos. So that would be 1 minus cos squared theta, using the same identity, that is equal to 1. So sine squared theta is equal to 1 minus cos squared theta. And then what I have here is 5 lots of cos squared 3 theta. Sorry, I was meant to put a 3 there. Okay, so if I expand this bracket now, I get 5 minus 5 cos squared 3 theta plus 5 cos squared theta, and you can see that these are going to cancel each other out, and I'm left with 5. So a few others. So 1 minus cos squared theta. Well, I know that is the same as sine squared. Oh, I said theta, but it says an x there, so it doesn't really matter what that angle is as long as it's staying the same. And if you remember, this means sine x squared. So whenever you square something and square root it, you just end up with sine x. So that is the same as sine x. That's a simplified version. And now this one definitely looks more confusing, but like I said at the start, if there's something I can factorize for, I'm going to do it. Now, you may, I'm happy seeing this, but you may want to say, do some substitutions. I'm going to do this down here because it's not something I would do. So if I let x equal sine theta and y equals cos theta, what I actually have, let's look at the right hand side, well, the right hand side of the plus sign. I've got sine theta squared, so I've got x squared and then cos theta squared, so I've got y squared. And if you think about that, that's cos theta squared times cos theta squared. So, or cos theta times cos theta times cos theta times cos theta, which is y to the power of 4. So you should be able to see that I can factorize for y squared, and it would be y squared plus x squared. Now, as you get more comfortable, you'll look at that and say, okay, well, I can factorize for cos squared theta straight away. I need another cos squared theta to make it to the power of 4, but treat it like x's and y's. And I need a sine squared theta. Now, when you see that, this is the identity. This term plus this term is identical to 1, so we're just left with cos squared theta. Now, you could write that as 1 minus sine squared theta, but that's 2 terms. That's less good, really, less concise as that one there. So if we ask you to solve this, you've now got it down to a single ratio. Same with this one. If we ask you to solve this, for example, is 0.5, you are now ready to solve and use your cast diagram. Here's another one. This one's a little bit more tricky because it hasn't got any squareds. So as soon as you don't see any squareds, you're going to think about using the other identity. Now, we know that tan theta is equal to sine theta over cos theta. So I'm immediately going to try and apply this identity. And I'm going to try and turn this all into tan. So to do that, I'm going to divide the whole equation by cos theta. So what I do to one side, I must do to the other side. That's okay, because that's not going to really affect it. So sine theta over cos theta, well, that's tan theta, so I end up with 3 tan theta. Cos theta divided by cos theta, they cancel each other out. Excuse me. So we end up with this. Now rearrange to make tan theta the subject, so add 5 and divide by 3 to both sides. And now we are ready to solve this, so that if they gave us a range, like for example 360 to 0, we can draw a cast diagram and we can solve that, no problem. Now this is a slightly different question. Now they're asking you to prove something. So what you can't do is treat this like an equation. You can't just manipulate both sides. So we're going to call this one the left hand side and we're going to call this one the right hand side. And you have to just basically pick one and you get it to look like the other one and then you've proven it. So I'm going to say the left hand side is identically equal to. So we're just going to focus on this and hopefully we can turn it into this bit on the right and then we have proven it. So how are we going to do that? This looks like dots to me. So I'm going to say that is cos squared theta plus sine squared theta being multiplied by cos squared theta minus sine squared theta. Why did I think that? Well, I've got 2 terms with a minus and this is a square term and this is a square term. So if I square root both of them, I get dots. There's no middle term with sine cos terms, so once you've seen enough of them, you'll spot that pretty quickly. Ah, right, well, this is interesting because that is now equal to 1. So I'm just going to, you can't skip any stages here, so I'm going to have to write that. which is the same as just this. So cos squared theta minus sine squared theta all over cos squared theta. Because of the identity, I can get rid of that bracket. Well, I can now split these this denominator between both terms, so I end up with cos squared theta over cos squared theta minus sine squared theta over cos squared theta. Right, so you see anything divided by itself is 1. We've got the sine ratio divided by the cos ratio. The fact that it's squared doesn't matter too much, or matter at all in fact, so we end up with tan squared theta. So therefore, left hand side is identical to the right hand side. You need to finish off with that statement. Now again, they could then therefore say solve this one on the left here, but you would use the bit on the right because it's ready to solve with just one ratio and go from there. Okay, I think that's all we're going to do for today's lesson. We're just going to practice using the identities and yeah, we'll see how it goes. Please reach out if you need any more help.